boat is traveling at a short speed of 30 miles per hour. It measures the bearing to the lighthouse to be south 68 degrees east. So, okay, we're going to go south, and then swing 68 degrees east to the lighthouse. Let me draw this here. Okay, so south, and it swings 68 degrees to the east. Okay, 20 minutes later, it has a different bearing measurement. Okay, so 20 minutes later, I'm going to make another one of these. And again, it swings out and goes directly back to the lighthouse. And it swings 20 degrees south and then to the east. Now, it states up here that the boat is traveling parallel. So the entire time it's traveling parallel, that means this distance from the boat to the shoreline is the same as this distance, be the same as this distance if we mention a third positioning to the lighthouse. And so it remains parallel, and we want to determine how far is the boat from the shoreline. So this distance here is the same as this distance right here. Okay, let's see, what else do we know? We know that it's traveling at a speed of 30 miles per hour. Okay, 30. So if this is 1 hour, it can travel 30 miles. But then it says when we stop here and it provides us with this bearing measurement, it's gone 20 miles. Well, it's gone 20 minutes. A good thing I saw that, 20 minutes. Well, 20 minutes would be a third of an hour. So if I take 1/3 times 30 miles, you can see that we end up with 10. That means this distance right here is 10. It's gone 10, in this case it's gone 10 miles in those 20 minutes. I'm going to draw this triangle right here, so it looks something like this. That's back to the lighthouse. Okay, we know that this is a distance of 10. Okay, so this is a right triangle, so 68 plus what measurement gives us 90? 68 plus 22. Okay, this is a 90-degree measurement, but then it swings east 20 degrees, so 90 plus 20 is 110. And now I'm going to take 180 and subtract 22 plus 110. 48. So this measurement is 48. Okay, so I do have a side and the angle across from it, so I have the sine of 48. And remember, at the very end, I want to know how far is the boat from the shore. So sine of 48 over the side 10 is equal to, how am I going to do that? Well, I think I should figure out what this length is, because I know this is a right angle. So this length right here would be this part right here. You can see this part would be right here. So I want to know, what is this? So I'm going to go sine of 110 across from x. When I solve it, x times the sine of 48 equals 10 times the sine of 110 divided by the sine of 48. Okay, let's see this. 10 times the sine of 110 divided by the sine of 48. Okay, so this is the measurement right here. It's not the distance to the shoreline, a direct distance from the boat to the shoreline. So this is 12.6448. I'm going to draw this triangle now, this right triangle. It's an ugly right triangle. And this diagonal will be this distance. This is 12.6448. And here's the boat. This is the boat. And here's the shore. We want to know what is this distance. And we can see this angle here is 68. Since we have a right triangle, we can use a primary trig function. So from this angle, I have adjacent and hypotenuse. So the cosine of 68 degrees equals the adjacent over the hypotenuse. And now to solve for x, I'm going to multiply by 12.6448 times 12.6448. Okay. Cosine of 68 times 12.6448, then I end up with 4.7368. Okay, so this distance back to the shore is 4.7368, and it's going to be measured in terms of miles.